So, and who wants to have a service with zero downtime? Basically, everybody, okay? It's the dream that every person that works in IT basically wants, okay? But it's really good to have a zero downtime service, because having a zero downtime service is not just a matter of technology. The technology is only the mean that we use to achieve that, okay? But it's a matter of balance between technology, risk, procedure, people. There are a lot of things that come into play when we talk about service like this. And today I'm here to show you how it's possible to have business continuity with Postgres, starting from 0 and reaching 100, okay? First of all, I'm Giulio, okay, and I'm an open source passionate from first years of the 2K, okay? I'm a member of the Italian European PostgreSQL community and Lean and DevOps practitioner and open source developer, member of the Barman team. If you don't know what Barman is, I'll explain later, okay? And I work on second quadrant as continuous delivery architect, developer for Barman, and 24/7 support engineer on second quadrant. Okay, let's talk about basic concept, okay? First, business continuity. It's like an umbrella term of two disciplines, okay, that are DR, or disaster recovery, and high availability, okay? Disaster recovery is a term that explains all the means and all the techniques and all the technology that is required to not lose your data, okay? And high availability are the discipline that takes care or reducing the amount of time, near 0 possibly, that it is required for you to recover your system in case of disaster, before, during, and after the disaster, okay? There are different kinds of failure and disasters, for example, from natural disaster, from human disasters, like someone that accidentally let stuff, things like this. And availability, obviously, is something that we can measure, okay? The objectives of the business continuity are basically two. The first one is the recovery point objective, okay? And this means how much data we can afford to lose in a case of a disaster. That it could be 0, okay? But there are situations when we can afford to lose something, okay? And this is one metric that you have to take in consideration when you think about business continuity, okay? And then we have the recovery time objective that is obviously connected with availability, okay? And is how much time you can afford to be down in a case of a disaster, okay? Because we're going to discover that time is money in this case, okay? Service reliability. Service reliability is a word that in the last years, okay, is a buzzword. The reliability thing is a buzzword. We have companies that are searching for service reliability engineer. The first of all, it's Google, okay, that continuously searches for people like this, because downtime is a cost, okay? If you are not online, probably one of your competitors is. So if you are down, you have to consider how many dollars, euros, or whatever is going to cost to you to be not available to your customer, okay? It's all about risk management. You have to consider and balance risks and countermeasures when you take reliability in consideration. And you have to consider 3 factors that are SLI, SLOs, and SLAs. in the specific SLIs are metrics that you decide, because are indicators of your service, okay? Service level indicators. Service level objective, SLOs, okay, are basically your ability to achieve something, okay, that is related obviously to your SLIs. And SLAs are something when you provide to one customer a service, for example, that have to be obviously greater than your SLOs. So you have to know your SLIs, practice your SLOs, and then contract your SLAs, okay? For this presentation, there are things that we have to consider, okay, that we are talking about PostgreSQL on Linux in this case, okay, that all the server we are going to talk about can be virtual or physical, there is no difference for this talk, that we take for granted that the storage is redundant, that there is a RAID, and that volume are redundant, and these can mounted, okay? So everything is okay from, an infrastructure point of view, okay? Because if we don't have this, we cannot proceed, okay? We are missing the basics. Okay, so let's move from 0, okay, to 100. 0 is basically one Postgres server. Okay, we have one server that does everything, okay, keeps the database, is always online, luckily, because his name is Hope, because you hope to have no downtime, you hope to lose no data, you hope that everything is okay 24/7, okay, for the whole year. Oops. Let's talk about this. We have RPO infinite, okay, or basically you can lose everything because you have nothing that saves you from losing data, okay? RTO is not applicable because you have nothing that saves you in case something goes down. You have to rebuild the full server from scratch, okay? Hope, the server, is not a strategy, but is a starting point. We could consider that, okay? And sadly, because I saw that, this is more common than you expect. There are a lot of companies that have their server and they hope they stay online, okay? Let's move a bit further, okay? We talk about one Postgres server and we add backups to that, okay? So we have a systematically, we execute pgdump, for example, using a cron, and we have a logical dump of the database every day at 4 a.m., okay? So day 0, day 1, day 2, we continue to archive the dump. Let's analyze this. How do you feel now? You think it's safe having backups like this? Still, RPO is infinite, and RTO is still not applicable. Why? Because if you don't test your backups, you don't know if they work or not. It is possible, okay? And unfortunately, also this is very common. There are a lot of people that think that if they do regular dump of the logical dump of the server, they are safe. They are not. Because also usually in this situation, they execute backup and they save it on the same server. So if you lose the server, you lose also the backup. So we need to improve that, okay? And how can we improve that? Okay. Adding one Postgres server, logical backups, and logical restore, okay? We are at 20% at the moment. So we have a Postgres server, we execute continuously logical backup every day, and we restore daily on an external server, just to be sure that backup is safe. We have to measure the time that it takes for us to recover the server, just to have an idea on how much time it's going to cost for us to recover that server. And we can define an RPO based on the backup frequency. So if we take a backup every day at 4 o'clock in the morning, and we have a disaster at 3:59 in the morning, okay, we lose 1 day of data. This is the RPO that we have, okay? The RTO is, I was saying, the time for recovering the server, okay? And then we have to add to that the time for provision another server, the time for configure another server, and hopefully you have data automated, okay, like using Ansible, stuff like this, and okay, the time to restore everything. And as I said before, you can measure it. But we think about everything, okay, or we are missing something that we can add to the equation. We can add time of reaction to that. Why I'm saying this? Because we need a reliable monitoring, okay? You have to be aware of the fact that something isn't working. So if this architecture is working for you, you have to monitor, by the way, what you are doing, okay? So if your failure happened at 3:59 in the morning, you have to be aware of that and be ready to recover that. Otherwise, the time to recover increases, okay? So we need to, as I said, have to reliable monitoring, and from now on, I assume that we have that in place, so we can move over, okay? This is an architecture that could work, okay, in some environments, like, for example, development environments, okay, that they don't care if they lose 24 hours of data, for example. But to improve and move over from the 20%, we need to reduce both RPO and RTO, okay? To do that, we exit from the realm of the logical dumps, okay, and we move into the realm of the physical backups. The first thing that we must talk about when we talk about physical backups is point-in-time recovery. And there are a basic concept that I have to give you to let you understand that, is the fact that with Postgres, you can physically copy your data directory, okay, and save it in another server, possibly, okay? And there are files that are called wall files that are basically differential backup, because a wall file keeps all the difference that happen on your database, so all the transactions that are executed on a database and are stored in that file, and Postgres can send the wall file outside, so you can save them outside. And if you have a physical backup plus the wall file, you can move forward and backward, okay, for the whole history from the backup to now, okay? And to do that, basically, you're using a time machine, because when I started working with point-in-time recovery for the first time, when they explained to me the concept, seemed to me a time machine. You can move, or in this case, we are talking about the Avenger timeline, but you can move about forward and backward and change time in every point, okay, create an alternative timeline and restart for that. Okay, so you can recover one moment before that someone drops a table, for example, okay? This is the starting point. PostgreSQL point-in-time recovery is part of the core of Postgres, okay? So it's fully open source. As I was saying, allow you to rebuild a cluster at a specific point in time using the walls and the backup. And it comes from a crashing recovery technique, okay? And started from that, and in the end, we use that until the latest technology, that is the streaming replication, both physical and logical, okay? And allow us to achieve zero data loss. This is the first brick that allows us to build the whole system to achieve zero data loss. We have hot-based backup, continuous wall archiving, I was explaining, and allow us to recovery. And there is an API that is part of the core that allow us to do this. So we want to continuously copy wall data. I was saying continuous archiving. There are different ways of doing that, and I'm going to show you. Then we want to have physical backups. So we want to physically copy our data directory, and there are different ways to achieve that too. And we want to recovery. So we want to copy the base backups from the location where they are saved to another location, put the new server in a recovery mode, allow him to copy the wall file, replay all the transaction that are stored inside the wall files until the point that we want, okay? That could be every point in time. You can do that manually, or you can use different tools, okay? And we, as Second Quadrant, as I said, I'm part of the Barman team, we created a tool that is called Barman that is specifically for this. We are actually at the version 2.8. Barman is open source. It's written in Python. It's written, developed, maintained by Second Quadrant, and it's freely available on pgbarman.org. Okay, so let's move over. We have one PostgreSQL server, and now instead of taking logical backups, okay, we introduce Barman into the equation. So we're going to move to the physical backups, okay? So this is the architecture that we want, okay, that we have. We have one server, that Postgres, and one server that is Barman, okay, that is responsible to continuously take backup from the physical server Postgres and storing the wall files. We can do that remotely, so Barman can, must reside on a different server, because as I said before, if you save your backups on your Postgres server, you lose the server, you lose the backups. So we want an extended server, so Barman can operate remotely for both copying the backups and restoring that. So you can copy a backup from, execute a backup from a master and recover that on an extended server. Okay, you don't have to recover locally on the Barman server. Can handle more than one server. Okay, and in the example I'm going to show, we take in consideration only one server, but with Barman, you can handle more than one. And we have customers that handle 10 servers using one Barman server, obviously with a big storage. Okay. Barman offers backup catalog and handling the archiving of the wall files, offer retention policies for both backup and wall file. For retention policy, I mean, I want to keep 1 week worth of data, and I take 2 backup a week. Barman takes care of removing, okay, the obsolete backups and related wall file when they fall off the recovery window that we defined, for example, okay? And then retention policies. As I was saying, there are different ways to achieve a hot backup. One important thing I forgot to say, for one big difference between a logical backup and a physical backup, so a hot backup, is the fact that a logical backup supposes that you inhibit access to your server while you execute the logical backup, okay? Using a physical backup, you can do that while Postgres is working. So you don't have to plan a downtime for executing that, okay? Sorry for the digression. So we have copy method, 2 methods Barman offered to do that. One is based on the Postgres streaming technology, okay? That is really and extremely practical when we talk about server on Windows, server on Dockers, or you don't want to use SSH tunnel that we use for async copy, okay? Or we have the async-based copy that have different advantage because we can use incremental backup and recovery using hard links technology from Linux. We can have parallel processes that start as spawners, sync processes and copy in parallel your backup and recover in parallel your backup. So speed ups the execution of physical backup. And we have network compression, bandwidth limitation, and these are only, the tip of the iceberg of the things that Barman can do, okay? Then we have worshipping. As said before, we have different ways of doing that. Basically, we have the archiving through the archive command. What is archive command? Archive command is an option that is inside Postgres that basically you give to Postgres a command that have to be executed. I will show you an example later of the configuration of that. That basically say to Postgres, copy this whole file in this location. It could be on a local storage, or it could be on RSQ command, or whatever you want, okay? Using archive command, we have an RPO that is around 60 megabytes of data. Why 60 megabytes? Because a whole file is always, we can say always, normally 16 megabytes, okay? So practically, Postgres writes the transaction inside the whole file. When it reaches the 16 megabytes limits, the whole is closed and is shipped to, in this case, the Barman server, okay? So the maximum amount you can lose, okay, is 16 megabytes. Another thing is important, the whole file is closed when it reaches 16 megabytes or when it reaches an amount of time that is defined in the archive timeout option, for example, every 5 minutes. So if you don't write 16 megabytes of transaction, anyway, every 5 minutes a whole is closed and sent to Barman in this case. Or we can use the streaming technology. That is based on Postgres core tool like PG receive_wall or receive_log. It depends on the version because we changed the name to wall that is easier to understand. And basically, every single transaction is streamed to the receiver in real time. So we can reach almost RPO 0 if we use the streaming technology. Okay? One downside is that is possible only from Postgres 9.2 or measure. Okay? Archive command is something that always been present, probably from 8 version, 8.4, if I recall correctly, of Postgres. So if you use a really old database, you are forced to use archive command. As said, we have an example of, obviously, the option that involve the streaming the archive command. From the PostgreSQL conf file, you have to enable the archive mode on, wall level logical if you want the streaming, and enable Postgres to send, okay, max wall sender, the processes that stream out the wall file using the streaming technology, and the replication slot, we will talk about them later, but basically it's a slot that holds all the whole file until they are correctly shipped through the streaming technology. So Postgres try to grant you the fact that if you don't have the whole file on your backup server, you have it on your Postgres server, okay? And this is an example archive command that I was showing. Basically, it's an rsync command. They say copy, this is a placeholder for the whole name to the Barman host in this directory, okay? And this is executed on every single whole file. We have Postgres in place with the option I showed you. I'm going to show you a typical Barman configuration. We have a server that I decided to call Stack. That is a description, okay? And this is an SSH command that we need to connect to a sync to the server to copy the backup, okay? In this case, I'm going to configure copy of the backup through async and wall shipping and streaming wall replication, because we can use both together just to be redundant and be sure, and Barman will take care of the duplicates, okay? So we have SSH command to copy the backup, connection info to communicate with Postgres. We have a retention policy, in this case, 6 months worth of data, okay? We are going to copy the backup using async. We are going to have incremental backups, okay? So we're going to save space on the disk, because when you use incremental backup, basically we use async to identify the file that have not changed. And we are going to copy only the file that have changed and use the links to create complete backup. In the end, we're going to save space on your disk. Then we have, I was saying before, we have parallel jobs that for copying using async. So we have 4 configured here. We have archive command configured. So we are going to receive all files through the archive command, and we are enabled also the streaming archive. And we are reserving a slot name that it's called Barman Streaming. Like this, Barman is going to receive wall file from 2 sources, okay, and executing backup. Summing it up, how do you feel now? You feel safer, probably. But still, we have RPO infinite and RTO not applicable. Why? Because a backup, even a physical one, is valid only if you test it. And Barman obviously reduces risk and saves time and saves your health also, okay, but need to be tested systematically, especially when you have custom scripts and stuff like that. And it's still a business risk. How can we improve that? Adding an external server that we can use to recover our backup. Okay, we are moving, incrementally over. So we have a master, a server that ships the walls and the backup are on the Barman server, and you can test your backup using the command Barman recover, okay, on an external one. Good. One of the most common critiques that we receive when we suggest this is this one, that keeping a server for doing nothing except testing a recovery, it's a waste. And this is basically wrong. First of all, because if you test something, it's not wasted space. Testing is an important part of your architecture. So considering testing something a waste of space, a waste of a server, is basically wrong, okay? Because if it's for your safety. The history of the IT, it's full of situations when people were sure to have a backup somewhere, and in the end, the backup was not there or was not working. And they lose a lot of data, okay? So, but beside this, you can use that recovered server for testing, for example, your application if they are based on Postgres. You can use that recovered server to doing business intelligence calculation, for example, that usually are really heavy for a Postgres master, and you can do that on the server that you recovered. You can use in development. There are a lot of options that you have to not waste that server that basically would not be wasted anyway. By the way, how can we do that automatically? Because we don't want to issue a Barman recover command every day just right after the backup manually. Okay, how can we do that? Barman offers a facility that is called Barman hook script. Okay, we have pre and post backup script, and we have pre and post archiving script, and we have retry option script that basically continue to execute the script continuously until it receives a success. Why I'm saying this? Because through the recovery script, you can create a bash script that connect to a remote server to SSH, stop a PostgreSQL server if is in action, issues a barman recovery from the barman server to the new server, okay, and start the PostgreSQL server again. This is enough to test that the backup is up, okay? You can also execute a couple of queries on the recovered server. You can do that through the script. But the fact that the server is starting is a good point, okay? And you should set it, obviously, as post-backup script. This means that basically you execute a backup, and before exiting from the backup process, this script is executed, so you recover automatically the backup that you just finished, okay? Just a couple of talks on this. The outcomes are that systematically you test your backup, and you can measure your time for recovery. So when the disaster strikes, you know exactly how much time it's going to take you, okay? As I said before, you have an identical server, and you can use that to recover if you have already it in place, okay, in case of a disaster. You can use that on an external data center, okay, because at the moment, if you recover, for example, from Europe to USA, it's going to take more time, but you have a server that is outside your normal data center, okay? You can do whatever you want. You can be creative and think just a bit out of the box to solve your problem. Okay, in this situation, okay, we have RPO almost zero, because we receive all files through streaming to archive command redundantly, okay? And we know that the backup worked because we recover it. We have RTO that is basically time of reaction on the alert that we already discussed, you have set up, okay? You are monitoring, and the time of the recovery that you measured because you recover it every day. So we can say, for example, that in this case we have RPO almost zero, RTO less than 1 day. Acceptable? Not acceptable? This is up to you. There are situations in that this is fully acceptable, but we can move forward because this is an entry-level architecture if we want to talk about business continuity. If you have less than this, probably you're doing it wrong. We have a priority now that is improve the RTO. How can we do that? We are entering in the availability field, okay? How can we do that? We have to use PostgreSQL replication. PostgreSQL replication is part of the core and is fully open source. It's based on the concept of a master and multiple standby servers that copy the transaction from the master, okay? It's an evolution on the point-in-time recovery. Why? Because the standby server are put in a continuous recovery state, so they continuously receive whole file and replay that, okay? The standby servers can be used for read-only operations, so you can balance read operation on both your master and your standby server, and can be streaming-based standby or file-based standby. There are pros and cons of both the technologies. And another important thing is the fact that we can have more than one standby cascading from one standby. So you have a master, one standby, another standby that copies the transaction from the standby, okay? We can have then synchronous replication, we talk about it in a while, that allow us to have global, fine control on global, on transaction until it, gives us global control until the transaction level, okay? And we have two safe replication that basically ensure that a commit is right only when the transaction is executed on both the master and the standby that is recovering disconnected to the master. This ensures us read consistency on the cluster, because we are sure that a transaction, when it's written on both the master and the standby. And this gives us RPO, 0. This is the zero data loss configuration. We will see that in a while, okay? But first thing, we want 2 Postgres server, obviously 1 master and standby, and 1 barman. So we're starting from this. Okay, we were starting from this, backup and streaming the words on barman. Then we have a standby that is connected to the master, and is also connected to barman. You can use the barman restore wall command to restore the wall in case it's not able to recover it from the master, okay? And we have a barman recovery server, okay? We can call this sigmatic cluster. This is an important concept. Why? Usually we consider the master, the standby, but if we for a second stop thinking about the concept of master and standby, we realize the fact that we can switch the role of the master and the standby in every moment. Okay, so in every moment the master is not available, the standby can be a new master, and vice versa. So if you stop considering the master and the standby, and you simply give name to your server, you have a semantic cluster. So I created, in this case, the Avengers, because it's cool. Okay, the Avengers semantic cluster, when the 2 servers can be master and standby, can be switched. This is an except from the PostgreSQL configuration of the Roger server, not the standby, the Roger one, that is in this moment is in a hot standby state from the configuration, that have a recovery conf file that is part of normal Postgres configuration, where we can read the existing standby mode and connect to Stark, okay, to streaming connection, okay? And as I said before, connect also to barman using barman word restore script to recover the Stark word, okay? So it's always almost up to date. You can plan to have switchover. This means manually switching the roles between Stark and Roger's servers. You should stop your application and obviously starting a downtime. We are talking about a downtime of 1 minute. Okay, if it's automated correctly, the downtime is around 1 minute. Okay, shut down the master, allow the standby to catch up if it's necessary, promote the standby to master, switching virtual IPs, that you should use virtual IPs that point your application to the actual master, okay, and starting it again, everything again. At this point, you can reconfigure the old master to be the new standby, okay? This is a switch that is planned. It is called switchover. We have failover, that basically the master is down, you promote the standby to the master, change the virtual IPs, you are in a degraded state, but you are up. Your master is now up again. You need to start again, create again a new standby. You need to recover it from barman probably to do that, but at least you are online in a matter of minutes, okay? Manual switchover, manual switchover procedure. Manual switchover is triggered manually, okay? We can do better than this, and we will see that. You should automate the procedure, okay? You can do it with Bash. You can do that using Ansible, for example. It is even better. Or you can start from, for example, Bash and enhance it gradually. Recapping the situation, we are in a situation where almost 0 RPO, okay? We have a reduced time of reaction and time of promotion. We require manual intervention. and this is now the faulty point, okay? We rely on monitoring, obviously, and we need trained people to do that, okay? Manual failover versus automated failover, I was saying before, is a matter of risk management. You can, if not done correctly, or you fall in the human error situation, you can finish in a split brain nightmare. Basically, split brain are two servers that are fully convinced of the fact that both are masters, okay? And this is not a nice situation. You should automate that basic on your the operation that you do normally and test it. It's your choice which one you want to do, but if you want to achieve the 100, okay, of business continuity, you should automate it. Obviously, I was saying a very good solution, automation for business continuity. This should lead you to reach 99.99%, more or less, of availability in a year. We can do even better, adding into the equation the synchronous streaming. This is the very same architecture that we were using before, but here the communication between the master and the standby and even master and barman is synchronous. I was saying before, you lose a bit of performance, but you are sure that every single transaction is written here, here, and also there. So when something is written in all the places, so you are always constantly in time, okay, between the whole server. So this is basically the zero data loss architecture. In this way, using synchronous connection, you are not going to lose anything, okay? Synchronous replication, you can use it on barman, so saying that the primary synchronous is barman, that leads you to have zero data loss backup, okay? Or you can use as primary synchronous connection the standby, that leads you to the zero data loss caster. So you are always on time on this. So reduce RPO or reduce the RTO, okay? It's a trade-off. And this happens only adding one line of configuration inside your Postgres configuration, that is this one. You specify that you want a synchronous standby on HA, that was our standby, and the barman receive wall, that was the replication slot used by barman. We are at the 90%. I'm going to close and I'm going to run because I'm late. So 100. How can we achieve 100? We have two Postgres server in synchronous, one barman server, one recovery server, and one rep manager. Rep manager is a product that is developed by second parent in this case, but there are other products that take care of this operation. They basically take care of switching automatically between master and standby. In case for a failover, for example, you don't have to do that manually, but it could be done automatically by rep manager, or can be used, obviously, can be triggered in some situation to execute an automated switchover between the master and the standby. What is more, we can push the boundaries over. We can repeat the same architecture. That's why automation is important, because if it's automated correctly, we can repeat the same architecture on different data centers. We can add PG bouncer that is responsible to moving connection between different servers. We can add virtual EPs. We can add S3 relay using Barmagoon scripts, so you can execute backups and archive them on S3, or you can receive wall files and archive them on S3. We can have multiple stand-based server in cascading replication. We can use Docker container to wrap our server if necessary, for Barman, for example, or for rep manager server, and execute logical replication backups. Conclusion of all of this: start with baby steps and keep it simple. As I showed you, you start with a single server. In a matter of 45 minutes, I explained you how to reach the 100, okay? Another important thing is invest in learning, because everything seems new to you, okay? And the only way to achieve your result is to achieve mastery. So learn and explore. As I said, practice is the only way to achieve mastery, okay? So regularly test stuff, okay? Plan regular, healthy downtime. As I show you, a downtime could be 1 minute for executing a switchover. In our architecture, in second quadrant, we execute switchovers at least once a week, okay? And usually people not even notice that, okay? Use switchovers also to perform upgrade over Postgres. You don't have to plan downtime because you disconnect the standby, upgrade it, promote it to master, at this point the master is disconnected, the old master is connected, you upgrade it and attach it again as standby. Obviously, smart downtime increase the long-term uptime of your whole architecture. I would like to know if you have questions, but I don't think I have enough time because they already appeared and told me that I have to close a couple of times. So you can search me around if you have questions, you want to know more about this. I will be here this afternoon around 5 p.m. to explain you how Barman works, and we are going to discuss basically not the same arguments, because we are not going to talk about, for example, Rep Manager, but we're going to discuss about disaster recovery. So if you have questions, you can ask me later or search me. That's all.